Hello everybody! So how safe are the NuGet packages that you use in your projects? This is Stef from Samayas and welcome to my channel. So I did a previous video about securing your DevOps pipeline. In there I looked into detail on how to use dotnet list package command, and I created a PowerShell script for it, since the dotnet tools out of the box don't support this command yet. Since then, I've created an Azure DevOps Marketplace extension called .NET Core List Packages Checks that includes this script. So in this extension, you can detect vulnerabilities in packages or outdated packages or deprecated packages against your current project or solution. And you can also do a deep scan. If you have packages you directly included in your project or solution that are being identified as vulnerable or outdated or deprecated, this package task will fail. If you have packages that reference packages that are identified as being vulnerable or outdated or deprecated, you will get a warning. So how to use it? Let's dig in. So I'll be continuing on a previous sample which I created for an Azure DevOps CI pipeline. And this project contains a library and a test project. However, in this scenario, we don't really care about the code. What is important is the NuGet packages. And for our library project, we have two packages. We have an internal framework package and we have system threading. For the test dependencies packages, we have Coverlet MS-Build, we have Microsoft.NET.Test.SDK, we have MS-Test Test Adapter, and we have MS-Test Test Framework. And at first sight, it all looks great. So now I've opened up a command prompt and I'm going to run .NET list test without specifying anything, which means it'll run on a solution and it'll list the existing packages. And it works greatly. It shows all the packages referenced per project. Now if you have a little look at the parameters, under the .NET list packages, we have three main parameters. We can go and look for vulnerabilities in our packages, we can have a look at deprecated packages, and we can have a look at outdated packages. So first look at the vulnerabilities, and if I have a quick look at the vulnerabilities, neither of those packages have direct packages which have vulnerabilities. Now there's a second parameter which includes transitive, and it means that it'll look for all vulnerabilities in our packages and all reference packages. And here we have a slightly different image. Even though we don't have an issue with the directly referenced packages, some of the sub-packages still have a critical issue on system.text.encoding.web. In the same line, we can execute and check if any of our packages are deprecated. And in first line, we have no issues again. And if we go and look a little bit deeper, on second level, some packages have been marked as deprecated. The last parameter to have a look at is the outdated package. And here it becomes a little bit more complicated. The version for Microsoft.NET.Test.SDK we currently have is in version 17.14.1. However, the latest version is version 18. And if we start looking for outdated packages, we might potentially want to update to the latest 17x range, but not necessarily go a level above. And here again, if we go in detail, we have the possibility to check for the highest patch version or the highest minor version. So let's add both parameters. And if we now have a look at the highest patch version, for our MS Test adapters, there's a new version and we could update it. If we have a look at our highest minor version, however, there's also a 3.11 if you want to go to. And so, as you can see, out of the box, .NET list packages allows us a lot of information about what is happening with our NuGet packages. And then it's up to us to decide what we want to do with it. Do we want to take action on it or not? Now when opening up NuGet, of course, we see exactly the same thing in our UI. We can see that for our MS Test, we're at 7.14, and we can see there's also an 18 available. If I look at the test adapter, it's the same thing. I'm at 3.10.4, and there's a 3.10.11, and there's a 3.11. And here the same thing. So we don't really need the .NET list packages. However, not everybody always goes and look to update everything. Now if you do include packages which really include vulnerabilities in first line, it is clearly shown with a warning sign. So, for simplicity, I created a build pipeline which links directly to this library build sample. I have a .NET restore on all my CSproj files. I have a .NET build on all my CSproj files. And I have a .NET test on all my CSproj files. And this build already succeeded. Now if we have a quick look at the standard .NET Core task, in the commands we have build, we have a NuGet push, we have a pack command, we have a publish command, we have a restore command, we have a run command, we have a test command, and we have a custom command. Let's have a quick shot with the .NET custom, and I call on my solution list package vulnerable. However, after some execution, even though this perfectly looks fine, the .NET list package vulnerable completely fails. Even though command line, it works like a charm. Now I've went to the Azure DevOps Marketplace. In here, you can just search for Samayas. And as you see, I've created 4 different extensions. Today, we're going to have a look at .NET list packages. And if you click through, you have a full description and this video about how to use this extension. If you want to use it, you just click on Get it for free. And so automatically, you can either install this extension on your Azure DevOps server, or you can download it for your local Azure DevOps server. Of course, if you want to install it, you need to have the necessary rights to do so. And so when you're done, you end up on this screen. So if you now go to your Azure DevOps server and you go to the general collection settings, you should have a screen that looks more or less like this. If you click through to the extensions, you should see all the extensions which are locally installed. And if your install was successful, you will see .NET List Package check installed. If you click through on .NET List Packages, you can see all the versions installed on your server. So now we are back in our demo pipeline and we're going to add the new task which we just installed. We go to plus and here we have a task .NET Core List Packages check. And so we choose add. This should be added between the .NET Restore and the .NET Build. If somehow our package checks determines there's an issue, there's no point in continuing building. However, this task must be run behind the .NET Restore, because we have to be sure that all packages and all package information is present. Now let's have a look at our package check configuration. As you can see, first we have the possibility for scope coverage. We can choose whether or not our package runs on the entire solution or only on a specific project. If we choose specific project, we have to specify the project. For now, we'll continue on a solution. Next, we have the scan type. We can scan on vulnerabilities, we can scan on deprecated, and we can scan on outdated. And by design, we also scan for transitive package checks. For now, first run, we're going to just run on vulnerabilities, and we're going to disable the transitive package check. And as you can see, the first run is successful. And if you have a look at our .NET List Package check for vulnerabilities, there's no issue. The task is successful, and so the build is successful. Now let's edit this task again, and now let's include our enable transitive package check. Let's save and rerun. Now, as you can see, with our transient check, we have the same that we had in command line. We have some issues in some of the sub-packages. And so our .NET List package is orange with a warning, and so also our pipeline went to orange, but the build didn't fail. Now I'm going to run the same build, but on a feature branch which has included those vulnerable packages first line, and let's see the result. And so now, as you can see, our build completely failed. It stopped at our .NET List package check and didn't even go further to the build. And we can see some vulnerabilities both in the first check and in the transient check. And since in the direct check we have some vulnerabilities, the task prompts to an error and stops all the rest. Now let's disable check for vulnerabilities and add a second. And now we'll look for deprecated ones and don't look for transitive packages. Let's run it again. And as you can see, there's no deprecated packages directly referenced in any of our projects, and so the build succeeds. Now if we activate the transitive on our deprecated, let's save and let's look at the result. And as you can see, again, we have some issues because in one of the packages there's some deprecated packages. So the task goes to orange, warning, and the build as well. And underneath we have the list of all the deprecated packages per project. And now we're back at our build, we're going to temporarily disable the deprecated ones, and we're going to add one for the outdated ones. And if we select the outdated options, we can either scan for all versions, we can scan for the highest minor, or we can scan for the highest patch. So let's first do the all versions, and let's run this one again. And so for this run, at first, I also allowed the add transient. But as we've seen in the previous sample, there's a higher version for Microsoft.NET.test.sdk, which is of version 18, while currently we're only at version 17.14.1. And that means that automatically our task fails, and so our build fails. But if you look into detail, next to the higher versions for those directly referenced NuGets, there's a lot of other versions which can also be updated. So let's return to the pipeline, and as we can see, we can enable or disable the transitive package check for all versions. However, if you go to the highest minor or highest patch, suddenly the property is not available because the tool .NET list packages doesn't support it. So let's rerun on the highest minor. And now, as we can see, for the test library, we don't have the Microsoft test project anymore that's posing a problem because it is at the highest minor. However, the MS-Test test adapter and MS-Test test framework have a higher version. I'm referencing 3.10.4, but there's a 3.11 available. And now, back at our pipeline, the latest option is to check on the highest patch. So let's rerun that again. And so even at the highest patch, well, I'm referencing 3.10.4, but there's even a version 3.10.5 available. So even that is making it fail. However, our library doesn't have an issue. And there's one final tweak we can do. And now instead of running on our solution to check for the outdated versions, we can specify a project. And so I specify only to check my library project. This way, I'm sure that everything is up to date on my library project and my eventual tests. I don't care whether or not I'm using the latest version or not. Now, in an ideal and simple world where you only have one specific library project and then one test project, this will work. If you have a more complex situation where you have 3-4 libraries and only one test, there it will fail. However, this is not a limitation of this task, but this is a limitation of the underlying .NET list packages, which either takes the whole solution or only takes a project. So if you really want to scan multiple, you need to duplicate this task and specify each of the project individually. So let's rerun. And so as you can see now, we only looked for library and not for test. And suddenly our check succeeded. And so also the pipeline. So as you can see, you have plenty of possibilities of making the ideal combination of what is acceptable for you or what isn't. And now finally, I have created an advanced section to my task. After playing around and integrating it on all my other build pipelines, I had some issues. I had one situation where I had one repo and subdirectories, and each of those subdirectories had a solution in there. Pipelines who were servicing those subdirectories didn't have an issue. However, .NET list, which is underneath command line which is executed, did, since it was executed in the root of the repo and it wasn't finding any solution. So by adding the advanced section, by default now you have the source directory, which is the root of your repo, and if in whatever scenario you need it to run in a subdirectory, you can just specify here subdirectory, and instead of running in the root, it will run in the subdirectory you specify. If you don't want to modify anything, by default, the advanced is just closed, and you don't need to look at it. These days, following up on used NuGet packages becomes more and more important. Whether or not you need to block the build is up to you. If you guys enjoy this content, please give it a thumbs up, subscribe to this channel and hit the bell sign. Or leave a comment down below.